In this video, we'll show you how to get the internal PID up and running quickly in the CFW500 drive. Now remember, that's the one that runs in the Soft PLC, not the drive. You might be wondering, why would I use this instead of the drive's built-in PID? After all, the drive's PID is a good, solid, basic PID implementation, right? Well, there are a number of reasons why you might want to use the Soft PLC version. I find the Soft PLC version easier to work with because everything is in true engineering units. It can use a second analog input that can be used to bias your process. That's really handy when you want this process to track another one. The Soft PLC version gives you more control over the process variable, gives you control over the sample time, something you can't specify at all in the drive's version, and it has high and low level alarms. And I just like the way the Remote HMI works better in the Soft PLC version. You actually see the units spelled out. Now there's a lot of subtle differences between this Soft PLC PID implementation and the one that's in the drive. So you can't just take the drive's version and copy it directly over to the Soft PLC version, what the manual calls the internal PID version. So if you're thinking about using the Soft PLC version of PID, it's really worthwhile to take a few minutes to watch this video where I point out all those differences and subtleties. It'll save you a lot of headaches. Here we go. I'm using the exact same hardware that we used in the PID Quick Start video in part 1, which is interesting because the I/O card that comes with that drive only has one analog input. That's important. If you aren't going to use the second analog input that the internal PID implementation has, which we aren't in this demo, then you don't have to buy an I/O card with two analog inputs. I like that. This is my configuration worksheet for this internal Soft PLC version of PID. And while at a quick glance, it looks a lot like the drive's version, once we've taken a closer look, you'll realize it's quite a bit different. This motor section is identical to the drive's version we used in the Quick Start videos, so I'm not going to spend any time on that. Now, if you don't know what the state of your Soft PLC is, then go ahead and reset it to factory default by setting parameter 204 to an 11. That doesn't affect any of the drive parameters at all. I'll do that just so you know exactly where I'm starting from. Now, the drive section has two differences. In the built-in PID, the frequency reference came from analog input 1 into the drive, right? But in the Soft PLC version, the analog input feedback signal comes into the Soft PLC, and then the Soft PLC sends the frequency to the drive. So instead of a 1 here, we put a 12. That's one of those subtleties I mentioned. Same thing for the auto manual switch. The drive gets that from the Soft PLC's internal PID application. The PID application will see that these I/Os have been allocated for those functions, and it will pass them to the drive. All the yellow cells are gone, so that section's done. Now we want that digital input to control this switch, so we set parameter 1015 to a 2. This also sets the bumpless mode. It's important to note that the Soft PLC's bumpless mode works in both directions, when going from manual to auto or from auto to manual. The drive's PID only does it in one direction, from manual to auto. Another one of those subtle differences, and yet another reason to prefer the Soft PLC version of PID. It gives you more control over the transition. We're going to leave it off for this video to keep things simple. You can learn more about bumpless mode in this video, which is on the WEG CFW500 drive, but the same concepts apply. And while we're here, let's set the manual set point to 0 so we don't get any surprises when we turn this thing on. One of the things I like about the Soft PLC version is you can do everything in native engineering units. You don't have to enter a 60 with an implied decimal when you mean 6, for example. To do that, you set up the units in parameter 510, we want PSI, and a decimal point in 511. We'll use the default single decimal place. So now, if we want to enter the set point by going to parameter 1011, there is no parameter 1011. If I increment the parameters, it skips from parameter 1004 straight to parameter 1. What's going on? Well, if we go to parameter 1000, we see it says no application because we haven't created a PLC app. And since we don't have a custom user program, there aren't any parameters to go with it. We want the built-in or resident Soft PLC application, so we go to parameter 103 and change it to a 1. Now if we go to parameter 1000, we see there is an application and it's stopped. Now it's important to note that this is just like any PLC. The PID application has to be stopped before making any changes. To do that, you just go to parameter 1001 and change it from a run to a stop. Also, the motor has to be stopped to stop or make changes to the Soft PLC. Now we can go to parameter 1011 where we can change the set point. Again, notice the set point shows up in PSI. We want 6 PSI, so that's what we enter. We don't have to remember to add that implied decimal. The Soft PLC app does it for us. For me, that's a big advantage of the Soft PLC version of PID because it makes my life easier. All of the PLC configuration stuff is in the upper left corner to remind you to do that first before making changes to the Soft PLC's PID application. Now you may remember that the drive's PID had a filtering option here where we could filter the analog input. The Soft PLC version doesn't have that. Why not? Well, because it's redundant. The analog input already has filtering built in. If you need filtering on the analog input, just use that. We'll start with the same PID coefficients we used in the Quick Start videos, but notice that they go to the Soft PLC parameters, not the drive parameter numbers. You can tell because the Soft PLC parameters are all greater than 1000. And look at this. The Soft PLC version gives you control over the sample time, which for some applications can be real important. Knowing the sample time is critical when optimizing PID using some of the techniques we outline in other videos. That's yet another benefit of using the Soft PLC version. Now, most of the time, the default blue value is fine, so that's what we use here. The process variable is in parameter 1013, and again, it's in true engineering units. Forward and reverse acting is a little different. Another subtle difference. In the drive's version, you simply chose forward or reverse. In the Soft PLC version, this is where you disable PID or you choose forward and reverse. We want forward or direct acting. This is where you specify how the second analog input reacts with the system. You can add the two analog inputs, take the difference, or take an average. This is great for those times when you want to inject an offset or even track another process. Another advantage of using the Soft PLC version of PID. We aren't using a second analog input in this demo, so we'll just leave that to default value. We have two new parameters that the drive PID didn't have, PVmin and PVmax. In the Quick Start videos, we made a big deal out of figuring out what the min and max speeds were that generate the min and max sensor outputs. These guys over here. Now that assumed 0 to 100% for this horizontal axis. In the Soft PLC version, you specify these numbers in engineering units. This is where the Soft PLC algorithm gets its scaling from, which is cool because maybe you have a minus 15 to plus 15 PSI sensor. You just enter those numbers in here and you're done. No fancy manipulation of the analog input to worry about. Another subtle advantage of using the Soft PLC version of PID. Now we're using a 0 to 15 PSI sensor, so I'll enter those values here. Again, in true engineering units, without having to worry about the implied decimal. So nice. Configuring the analog channel is almost identical to the drive version, except we need to tell input 1 it's being used for the PID feedback signal to the Soft PLC, not the drive. In the drive version, that was done in parameter 203. And I'll add a little filtering on the analog input. Again, keep that small. Large values will reduce the responsiveness of the PID algorithm. We're not using sleep mode in this demo, so let's go to parameter 1028 and set it to a 0 to turn it off so it doesn't surprise us. You can learn how to use sleep mode in the sleep mode video. Finally, we need to configure the display. It's the same as the Quick Start video, except the set point comes from the Soft PLC set point, and the process variable comes from the Soft PLC process variable. Remember that we set the Soft PLC units back here. Well, great. All the yellow cells are gone, and we're left with white values and blue defaults, which tells us we have a complete PID configuration. I went ahead and entered all those into the drive. In parameter 1000, we see the Soft PLC is still stopped, so we go to parameter 1001 and set it to a 1 to enable the Soft PLC and get it running. And parameter 1000 tells us the Soft PLC is now running. Perfect. In parameter 1002, we can also see the scan time in milliseconds, another thing you can't do with the drive version. Back up to the display main level. Again, I love that the Soft PLC version of PID shows clearly on the display exactly what the units are. Let's start in manual mode, which is this way. Yeah, the Soft PLC uses the opposite contact definition relative to the drive's built-in PID. I'm going to overwrite the labels in the video to serve as an obvious reminder they're different. Okay, we're in manual mode, and the manual set point in parameter 1012 is at 0% of the motor speed. Switch to run, and the drive takes the motor to the minimum speed we put in parameter 133, which corresponds to this many RPMs. Let's change it to 50%. And once I get past the min speed, the motor responds as I scroll. Manual mode is a great way to test out your system. In particular, you can use this to make sure the motor is spinning in the right direction. Our pressure is increasing as the motor RPMs increase, so we're operating in the forward direction. Perfect. Save that and escape back to the main display. We see the RPMs up here and the motor's current down here. I'll switch to auto mode, and sure enough, PID automatically adjusts the motor speed to get the system pressure to the 6 psi we asked for. But it's taken a long time. Apparently, the Soft PLC scales the PID coefficients differently than the drive's PID does. If you watch any of the videos that show you how to tune a PID loop, then you know I typically just double the P coefficient until things oscillate and then back off. If I go to parameter 1017, I can adjust the gain in real time. Whoops, went too far. My system started to oscillate. Let's try a gain of 3. Open and close some valves. Yeah, that's a lot more responsive. We can play with this all day, but you get the idea. Watch this video to learn how to tune a PID loop. If we change the system pressure to 5 psi, PID automatically adjusts the motor speed to accommodate it. Perfect. How about 7 psi? Yep, the drive tracks the new setting almost as fast as I can change it. Cool. Well, that ought to be enough to get you up and running. I put a link to the spreadsheet configuration tool in the description below the video. Now please, just use that as a guideline. I can't guarantee everything is perfectly correct. Any questions? See the manual. Now if you do find an error, please leave us a comment below so we can get it updated. Click here to learn more about the WEG CFW500 variable frequency drive. Click here to learn about Automation Direct's free award-winning support options, and click here to subscribe to our YouTube channel so you'll be notified when we publish more videos like this one.